Hello everyone. In the last videos, you will learn which are the different keyword search algorithms in text mining. What is keyword search and what are the challenges of the keyword search in social media? Now we move ahead with the next concept, that is classification, clustering and transfer learning in social media. So let us understand the classification. What is classification? Classification is applied mostly on a label data, the data in which the output is specified for the input instances. So you are classifying the input instances into either a class 1 or class 0. There are different classification algorithms available for content based classification. In social media, you have to apply the content-based classification or link-based classification. So there are widely used algorithms are Naive-Bayes classifier and TF-IDF classifier. IDF is the product of TF and IDF scores of the term. Let us first see Naive-Bayes classification. You already studied this Naive-Bayes classification in machine learning. It is a probabilistic algorithm which calculates the probability of each word in the text or a sentence, and the word with the highest probability is considered as an output. It is totally based on the Bayes theorem, which is a conditional probability. Probability of A when the B occurs, that is the probability of B when the A's exist, into probability of A divided by the probability of B. For example, what is the probability of X place when there is a no rain? So for that purpose, you have to calculate the probability of no rain when X place from the given instances multiplied by probability of X place, how many times the X place, divided by the probability of no rain. So to calculate the probability of X place when no rain is, you have to first find out the probability of no rain, probability of X place and probability of no rain when X place. So this is a Naive-Bayes classification. Now the next is TF-IDF. What is TF? TF stands for the term frequency. This summarizes how often a given word appears within the document. TF is nothing but number of times the term appears in the document. The term means the word. For example, the, where, and, machine learning. So these, suppose for example, take an example of blogosphere in social network. The blogosphere is composed of the different blocks, and if you want to do the topic classification or the topic detection, in that you have to find out the number of terms which are present in the block, and you have to find out the frequency of the terms in the document. Based on that, you have to classify the given post into the different types of the post. So here the TF gives you the frequency of how word appears or how many times the word appears in the given document, to the total number of words in the document. The second is IDF. IDF stands for the inverse document frequency. The term is very common across the document, has a less score. For example, A and the. These are the common words or the terms which appears in every document. But there are certain terms which are rarely appears across the document. So IDF is actually looking for the terms which are across the documents. IDF stands for ln, number of documents divided by the number of documents the term appears in. Now let us go ahead with the challenges that are in the social network to apply the classification algorithms. You cannot directly apply the classification algorithm to a social network. There are a lot of challenges in the social network. The first challenge is that the social network contain a much larger and non-standard vocabulary as compared to more standard collections such as the news collection. Second challenge is the social network data is often noisy than other standard collections or the other standard data sets. And the very important is that in a social network is composed of the links. So the document or the data, it also contains certain links to the other part of the network. So it is very important to consider these links for classification purpose. So for that purpose, normally the classification algorithms are based on content and linkage part in the social network. So the hypertext categorization method is used. It uses the content and the labels of the neighboring web pages for classification purpose. When the labels of all nearest neighbors are available, then Bayesian method can be adapted easily for classification purpose. When the labels of all the nearest neighbors are available, then you can use the naive-Bayes classification. But if the labels are not available, you have to think for the other method. So the real challenges is in that when the nearest neighbors are not available with the labels. In such case, a relaxed section labeling method is proposed in order to perform the classification. Two methods have been proposed in this work. The first is the completely supervised case of radius, one enhanced linkage analysis. Here the labels are specified, so it is very easy to do the classification. And the second method is when the class labels of the nearest neighbor are not known. So relaxed section labeling is used in that scenario. Now the next concept is clustering. All of you know the clustering. The general goal of clustering is to group similar objects into one cluster while partitioning dissimilar objects into the different cluster. In a social network, vertex properties describe roles of a person while the topological structure represent relationship among the group of people. The problem of clustering arises quite often in the context of node clustering of social networks. The problem of network clustering is closely related to the traditional problem of graph partitioning. Let us take an example, clustering example. This is a given co-author graph where the nodes define or the vertex represents an author and edge represent the co-author relationship between the two authors. This is a co-authorship relationship between the two vertices. Means this node is connected to this node, means there is a co-author relationship exists between the two authors. In addition, there are author ID. This R1 is the author ID and the primary topic associated with each other. That this is nothing but the research domain. This author is writing the paper in this research domain. So let us do the clustering. There are different clustering algorithms. First is you can do the clustering based on the structural property. So you can form the cluster based on the connections. So it is all these nodes are strongly connected to each other and these are connected to each other. So you can form the two clusters directly based on the structure. Then the second is the attribute based cluster. Attribute based cluster means you have to see the vertex property. So here in this cluster all the nodes which are talking about Skyline and XML document, and this is Skyline and Skyline means you are clubbing together all the authors who are in a same research domain. Except this R8, all are talking about Skyline, whereas in the second cluster all the nodes are working on the same research topic, that is XML. So these are the all authors which are writing the paper on XML document. So even if there is no connection between R3 and R4, we can do the clustering. We can include it based on its attribute property. Then this is an example of structural as well as attribute clustering. So here you have to consider the property of attribute as well as the structure of the graph. So based on both the properties, or you can say hybrid property, you are doing the clustering of the given graph into two clusters. Thank you.